So today, as I said, we're talking about hierarchical analysis of variance. This is a really strange way to do things, but it's one of those things that sometimes happens, and that's why we're going to talk about this today. There we go. So usually all of our factors, independent variables in other words, are crossed with each other. In other words, all levels of factor A occur with all levels of factor B. Right? So each level of A occurs with every level of B. A1, B1, A2, B2, A2, B1, A2, B2. I think I said them all right there, for example. And I'm not talking about subjects. We have nesting with subjects all the time. Whenever we're in between subjects variable, subjects are nested within the levels. I think you can see where this is going. Today I'm going to talk about when levels of an independent variable are nested within another variable. Okay. This isn't an intractable problem, but it's something the best way to avoid the problem is to not do this. But it does come up, and that's what I'm going to talk about. So sometimes things are different. Sometimes this is usually because of some constraint on the research. This is not something you would design into a study. It would be ridiculous to design this into a study. So here's an example. And in fact, this is a real world example. This was done at a hospital in Toronto, or 3 hospitals. Is it 3? Yes. 3 hospitals in Toronto in the 1980s. A friend of mine consulted on this. One of the ways, as a graduate student who has some ability in psychology, in statistics, usually biostatistics, so psychology, biology mostly, is you can make money consulting. You can't make a lot, but you make something. So what you do is, because a lot of times, especially medical researchers, don't have any stats. So they need somebody to come in and do it, and you got them over a barrel, and you say, yeah, that'll be $200 an hour. And I've done that once. I did it for 15 minutes and told them this wasn't, you designed this poorly, you should do it again. And that's all I said. And then I said, that'll be $200. My friend Todd did this, who I mentioned before, who is a flawed person, best. Todd was consulted by some people, and this wasn't them. I think they knew what they were doing, but they had no choice but to do their study this way. This was different medications for pain for burn survivors. So you have 6 drugs, and drugs are nested within hospitals. There are 3 different hospitals. Now, originally, what you might think to yourself is just ignore it. Hospitals are the same. No, they're not. Each hospital has a different staff giving the drugs, right? The food's probably different in each hospital. It's still garbage, but at least it's different in each hospital. There's all kinds of possible differences here. So you have to take it into account, don't you? Take it into account. But the problem here is that drugs aren't crossed with hospitals. That was impossible for a couple of reasons. The first reason is resources. You couldn't have each hospital have each drug. It just wasn't possible. Secondly, and this is sort of happily, there weren't enough burn survivors. There weren't enough people that were in severe pain from this is like your whole body. This is like really hurt my hand. Okay. So we have 5 burn survivors per group. So in other words, we have these different groups. We have 6 groups. So across Toronto, in these 3 hospitals, there were 30 participants in this study. So you see, you want to take hospital into account, but the problem is hospital is not crossed with drug, which ideally it would be. Because you could look for a drug by hospital interaction and say that shouldn't be there, right? But a drug effect, you hope that's there. Okay? So you understand the design, and you understand why this happened. It's just a constraint based on the real world. The other problem was, and this is what my friend said, could you do another set of trials crossing everything when, sadly more people will get burned? And they said, no, this is the money we have. This is all we can do. Oh, okay. I guess we'll do it your way. So you have to take the hospital variance into account, ethically, right? Because you're doing a drug trial. This is about making people's lives a little more bearable. So it's weird here because we have hospitals, then drugs within hospitals. So the first thing you list is the between subject factor, which is hospitals. You start at the top of the hierarchy. Okay? And then you go any nested factor, which is also, in this case, a between subject factor, drugs within hospitals. And then you do subjects within drug-hospital interactions. And it's not S within D within H, it's just S within DH. Because from the subject's point of view, sort of looking up at the design, they can't see anything over here, I'm within an interaction of hospital and drug. Does that make sense? So you think of it that way, it's kind of like the subject is looking up in that table and they can't see beside them. So they're looking up and going, I'm in drug 1, hospital 1. I'm in a drug-hospital interaction. I don't know what everybody else is in. So when you do the analysis, the mean square you're going to divide by, for both of these, hospital is drug within hospital, is subjects by drug within hospital. The one we care about for our result, to find out if there's a difference between the drugs, is the drug within hospital effect. That's what we're going to care about. We really don't care about the hospital effect. In fact, we would be surprised if there was not a hospital effect. I guess you could probably make the argument, if there was no effective hospital, that you could redo this as a simple one-way ANOVA. The problem is it's going to make the error term bigger. You just ignore the hospital effect, you just say you got a one-way ANOVA with 6 levels. You probably could do that. That's not going to make your error term bigger, and you're going to lose some sensitivity in detecting a drug effect. So you're really over a barrel here. This is really tough. But in this case, you kind of have to do it. So you expect probably to have a hospital effect. And like I said, if it's small enough, you probably, if you're getting an F around 1 or something like that, you might, for hospital, you might say, you know what? I'm just going to do this as a one-way ANOVA. So there are cases where this kind of design is useful, and it's typically things that are constrained because you're out in the field. You're not in a lab. You would not design this like this in a lab. If you did, the person who you were working with, like your supervisor or something, or your colleagues who you talked to your work about, didn't look very closely at your design. Or you were dumb enough not to ask people what they thought of your research design. You should always do that. Science should be collaborative and social, so you should always ask people, what do you think of this? I keep telling my honor students about their graphs. They say, I like them that way. I said, do them 2 ways and ask people what they mean, which ones they like better, because you're probably wrong. Because I've had that experience many times where I have graphs, and I go to people and I say, what does this mean? And they go, I don't know. Oh, that one I know what happened. It's the same data, just graphed it. So you'd always talk to people about your design. In this case, this is what happened. They brought in a consultant. They were smart to bring in a consultant. And he said, you kind of got to do it this way. Sorry. Give me $500. So it's, I'll do it. Okay, the analysis is done, that'll be $500. I remember explaining this to about, well, I'll talk about empty cells next time, but they actually had whole missing cells, which was great. And yeah, I just went downstairs. It was a different lab. It was weird at UT. We were in this building. There was also the provincial IDEC, where they do like cornea transplants. They had them stored there, so guys would show up with coolers. And you realize it's a cooler full of human eyes. I said, you get more subjects, and you need more eyes? I said, yeah, I guess. The guy thought I was going to fix everything. He said, I called this professor in psychology, and he said, talk to David Brodbeck. I said, you didn't say David Brodbeck would fix your study. It's done wrong. That'll be $200. Did it when I was a postdoc, too. And it was really cool. And this woman didn't know how to analyze her data, and so she came to me, and I gave her a hand. And then I get this phone call from her father. He's a graduate student. And he's like, well, I'm a medical doctor. I said, well, I have a PhD. I said, wouldn't you do a t-test? I said, what are the assumptions of a t-test, and which one would you use? And he was completely flummoxed. I really enjoyed that. It was like one of those rare moments when you go, it's one of the few times in my life I can go, do you know who I am? Really, I can't do that. So here's another example. So you understand this design. It's weird and it's crazy and don't do it, but you can see why it would happen. So here's another example. This is with 3 subjects. Oh, boy, that came in. So we got A1, A2, B1 to 4, C1, C2, and we've got, here are our groups, 1, 2, 3, 4. So move that over. So now we have nesting within of variables, and a within subject variable as well. So what are our independent groups are? What are our between subjects factors? Don't worry with the nesting right now. What are our between subjects factors? Well, it's got to be A, B, or C, guys. Is C between? The different subjects get different levels of C. Oh no, everybody gets every level of C. It's a within subject variable. Yeah. B is different because different subjects get different levels of B. But wait, there's more. Yeah, A is 2. And when you talk about B, do you talk about B by itself? No, it's B within A. Yes, so that's also a between subjects factor. So we got A, B within A are between, and then subjects are nested.
Can you go back to the hospital one, just so I can look at that?
Sure, let's go back to the hospital.
The design?
Oh, the design, let's go
Yeah.
way back. Okay, yes, and?
Okay.
So you see different drugs are within different levels of hospital. Right?
Yeah.
So drugs within hospital. 1 and 2 are within 1, 3 and 4 are within 2, 5 and 6 are within 3.
So like, if we did this with using our standard AB labels,
Yeah.
the hospital would be like A and the drug would be B.
Yeah. Yeah, sure.
So like normally that
Sure. Make sense now?
Yeah.
Yeah. You see what's crazy? Because that's what we're testing, not just drugs by themselves. Okay, so back to our example. So Yates order is your friend. The idea of between subjects within. The final piece of that is we have a hierarchical design. It's, well, it's top of the hierarchy first. So it's going to be A, B within A, and we're going to go from there. Okay? So keep that design in mind. A1 and 2, and then B1 and 2 are within A1, 3 and 4 are within A2, C1 and C2, everybody gets every level of C. Okay? All right. So, questions about this? I think there's a tour. After school here. That's great. No. It's recruiting. That's what I was doing there. Recruiting. Just a little tiny, just a little bit. Why? Don't say that. Don't say things like that. She's horrible. So, if you look at this, you see now, we've got, just like I said, right? A, B within A. When you interact B within A by A, that would not make any sense. So let's do subjects. Subjects are within A, B interactions, yeah? They're not within subjects within B within A. Again, the subject looks up and sees I'm in A1, B1. They can't see over here or over here, they can just see up. Okay? Well, you can't go subjects within A, B by A, so, we're done. Let's do the within. C. C by A, C by B within A, C by S within AB. And as Gordon Ramsay says in all his cooking videos, done. See how he said it?
And what kind of sandwich are you?
What's that?
And what kind of sandwich are you?
Oh, hot dogs.
An idiot sandwich.
You donkey! Shut it down! See episode of Hot Ones where he was eating the shitty ones? It's very good. Hot pan, olive oil, yeah. Sear. It's always the same thing. I love him. I want to hang out with him. We should get him an honorary grade.
So get him as your GPS voice.
I want that.
I do.
I had GLaDOS from Portal as a GPS voice for a while. And it would give you wrong directions. We just say, turn right, and it was supposed to turn left. It's like pretty great.
Like I watch him, I work with someone with a similar personality / attitude in kitchens of his kitchen nightmare type days. And
Wow. Yeah.
like the first week that it happened where he would do a big sandwich and like scream at people and
Yeah.
stuff, I went up to that one guy and I was like, we're equals, you can't talk to me like that. And just like walked away. And every time I see Gordon Ramsay, like I know it's TV, but I get mad.
Well, the difference is, Gordon Ramsay has 24 Michelin stars, and I don't think Bruce had any.
No.
I'm just guessing. Yeah.
But like even so.
Oh, no, it's not nice.
people.
It's not nice. It's not nice.
But thanks doesn't make me TV.
So recruiting the young kids is really important.
You have to get them young and just like make sure
Exactly.
they don't know any of
My daughter was coming to campus when she was just a little older than that. So what we're going to do now, let's work at degrees of freedom. It's not surprising that this works. A minus 1, so that's going to be 1. B minus 1 times A, right? A minus 1 times AB, blah, blah, blah. So, and we're going to test, you always test this with what's below it that has it and subjects in it, right? So C with C by S within AB, C by A, C by S within AB, C by B within A, by C by S within AB. All right. So, you should be able to go the other way too. You should look at design like an analysis variance table and say, what's the design? And I think I told you guys this the other day, that the first thing I do when I'm reviewing an article for a journal is I draw out the design, because people do stats wrong. They usually don't, but 1 out of 10 of the papers I get, somebody's done something, they've just done it wrong, and no one's caught it. So you help people, because if you don't, you're a jerk. So let's look at this. We got B subjects within B, AB, and A by S within AB. Okay, do we have any nested variables? Well, except for subjects. Happily, in this case, no. Let's see. How many levels of B do we have? 3, because we have 2 degrees of freedom for B. Are A and B crossed with each other? Is there any nesting? I don't see B within A or A within B, so we're good there. So how many levels in A do we have? Also 3, right? Subjects are nested within B. That means different subjects or different groups are within each level of B. But that also should tell you that, well, that's one way to look at it. The other way is it always goes between subjects within. Oh, between. So we have different groups for B1, B2, and B3. The only thing left to figure out is how many subjects we have in each group. So what's little a? There's 2 ways to do this. There's the easy way. So I think the easy way is like the best way for me. And that's to look and say we have how many observations in total? 36, because we have 35 degrees of freedom. We have 9 cells. 36 divided by 9 is, I know your calculator, thank you, 4. N equals 4. 10 marks in the final exam right there. No, you practice them. Sarah, these are actually easy to do in practice. It's a matter of practice. At first, this is the first time we've done this going this way back. You practice 8 or 10 of these, and you will be getting, when I set up a Facebook study group for the course, you will be getting a series of review questions. Don't worry. It's a thing that I do. Well, you should join. You will have to join Facebook. You don't have to. I can email you the questions, but then you don't get the interaction with everybody else in the class. All right. So remember about these designs. Using Yates order, you can figure out the design and the error term for anything. You can always figure this out. Here's a problem. Is hospital a fixed factor or a random factor? I don't know. Like, I can make a case that it's fixed, but really, I want to generalize to every hospital. But then they expect the values that mean squares don't work out. So, it's probably bad. Like, you shouldn't do it. You should really avoid these kind of things, because in this, and usually you're in the field, and these kind of variables tend to be things that you could make a very strong case that they're supposed to be random factors. That changes things. Avoid these designs like the plague. Or something worse, because the plague is pretty curable. That's a strange thing to say. But it really is. All right. Okay, so that's